The deep squat is a test that challenges total body mechanics when performed properly. It is used to access bilateral, symmetrical, and functional mobility of the hips, knees, and ankles. The dowel held up overhead accesses bilateral, symmetrical mobility of the shoulders as well as the thoracic spine. The ability to perform the deep squat requires appropriate pelvic rhythm, close kinetic change, dorsiflexion of the ankles, flexion of the knees and hips and extension of the thoracic spine, as well as flexion and abduction of the shoulders. The hurdle step is designed to challenge the body's proper stride mechanics during the stepping motion. The movement requires proper coordination and stability between the hips and torso during the stepping motion, as well as single leg stand stability. The hurdle step accesses bilateral functional mobility and stability of the hips, knees, and ankles. Performing the hurdle step test requires stance leg stability of the ankle, knee, and hip, as well as maximal close kinetic chain extension of the hip. The hurdle step also requires step leg open kinetic chain dorsiflexion of the ankle and flexion of the knee and hip. In addition, the subject must also display adequate balance because the test imposes a need for dynamic stability. The inline lunge is a test that places the lower extremity in a scissored position, challenging the body's trunk and extremities to resist rotation and maintain proper alignment. This test accesses torso, shoulder, hip and ankle mobility and stability, quadriceps flexibility, and knee stability. The ability to perform the inline lunge test requires stance leg stability of the ankle, knee and hip, as well as apparent close kinetic chain hip abduction. The inline lunge also requires step leg mobility of the hip, ankle dorsiflexion, and rectus femoris flexibility. The subject must also display adequate stability due to the rotation stress imposed. The shoulder mobility screen accesses bilateral shoulder range of motion, combining internal rotation with adduction and external rotation with abduction. It also requires normal scapular mobility and thoracic spine extension. The ability to perform the shoulder mobility test requires shoulder mobility in a combination of motions, including abduction, external rotation, flexion extension, and adduction, internal rotation. It also requires scapular and thoracic spine mobility. The active straight leg raise tests the ability to disassociate the lower extremity while maintaining stability in the torso. The active straight leg raise test accesses active hamstrings and gastrocoelus flexibility while maintaining a stable pelvis and active extension of the opposite leg. The ability to perform the active straight leg raise test requires functional hamstring flexibility, which is a flexibility that is available during training and competition. This is different from passive flexibility, which is more commonly accessed. The subject is also required to demonstrate adequate hip mobility of the opposite leg as well as lower abdominal stability. The trunk stability push-up tests the ability to stabilize the spine in anterior and posterior plane during a closed chain upper body movement. It accesses trunk stability in the sagittal plane while a symmetrical upper extremity motion is performed. The ability to perform the trunk stability push-up requires symmetric trunk stability in the sagittal plane during a symmetric upper extremity movement. The rotary stability test accesses multi-plank trunk stability during a combined upper and lower extremity motion. The ability to perform the rotary stability test requires asymmetric trunk stability in both sagittal and transverse plane during asymmetric upper and lower extremity movement. These modifications are for our osteoporosis target population, and it's because pain was experienced during the assessments.